Krishna? Yeah. So tell me, I mean, what are the observations on result sheet 1?
So when you take the log, the R squared value is going up.
Okay. Now, what have we done in this particular exercise? What we have done?
So we have regressed savings. We are trying to find the relationship between savings and GDP, with
Right?
savings being the dependent Y
Hmm.
and GDP being the independent X. Then after that, we try to compare the log value of GDP and the log value of savings, and we try to regress them over each other. Then we also take the log value of the scale, like log of scale, like some constant times GDP and log of some constant times savings. And in the end, you have also made a mention about no constant, that is like it should pass through, it should have a zero intercept.
So the first part of this result sheet, if you see, it is basically the estimated model in arithmetic scale. Am I right? The model is estimated without making any log transformation of the variables. Isn't it? You see command number 2. I'm talking about command number 2. This result sheet, if you see, here the model is estimated in measuring with measurement of the variables in arithmetic scale. Am I right? Am I right, Abhinav?
Yes, sir.
Then what we are doing, we are making log transformation of the variables. Then this is the set of results with the variables being measured in logarithmic scale. Then we are changing the scale of the variables first. Say scale of GDP, that is changed by 5, a factor 5, and that of savings, it is changed by a factor 6. And we are generating new variables. First we are changing the scale, then we are making log transformation. You see command number 6 and 7. So we are generating new variables twice. Here we are straightaway making log transformation of the variables and then we are estimating the model. Here we are first changing the scale by 2 factors. For GDP it is 5, for savings it is 6. And after changing the scale, we are making log transformation of the variables. Then we are estimating the model again. In fact, yesterday's question was, how will the results change, or how will the results differ between these two models? One model is this one, log of y1 versus log of x1. Another model is log of y versus log of x. And when we compare these two sets of results, you can very well see the difference is only in respect of intercept. You see intercept is different. You see the standard error is different, and also the t statistic. Other than the results for the intercept, rest of the results, if you see, they remain the same. And the mathematical derivation to this is given here. When we are just changing the scale, multiplying the variable by a constant factor, say we are multiplying here y by w1 and x by w2 and then taking log transformation of the variables, we are essentially getting a model which is similar to the model that is obtained simply by making log transformation of the variables. The only difference here is in respect of the intercept. Here it is alpha star, here it is beta 1. Is it okay? Is it okay?
Yes, sir.
Here, for your greater clarity, I can just change this. This is basically for U and this is for V. This is for V. These are basically estimated variances of the random disturbance term, which is basically mean of RSS. And if you see these regression results, mean of RSS, here you see this is the mean of RSS. And here you see the mean of RSS, this other model here. 4086. Here also you can see, I mean, largely converging. Okay. So what I'm saying that when we do log transformation of the variables, we can first change the scale and make log transformation, or we can straightaway make log transformation of the variables. The difference in the results would be largely in terms of the intercept, its standard error, and hence the t statistic. Otherwise, the rest of the results would remain the same. Here, of course, we are assuming that the two random disturbance terms, U and V, have the same distribution. Okay, and the last part of this result sheet, it is basically in terms of dropping the intercept and including the intercept. How the two result sets will differ. So command number 9 and 10, if you see, in command number 9, it is basically without intercept. In command 10, it is with intercept. And if you compare the results, you will see large scale differences in the results, what already we have discussed in yesterday's class. Now, let us go to result sheet 2. Result sheet 2. There are few models, alternative models. You know the variables. Already we have discussed in earlier classes. I would just suggest you to go through these results and then we'll start the discussion on this. Sorry.
Sir,
Yes.
sir, what is this underscore cons variable?
Where?
Sir, in the left tab of every like command, the output of every command. There is ROC, then con, then underscore cons.
Okay. Here ROC is basically the dependent variable. Okay. And this CON is basically the independent variable. Here it stands for market concentration. And this underscores cons, this is basically the intercept. This underscore cons, this is basically the intercept. You see, this is common across the models. This is common across the models. Let me just tell you, the first model is estimated with ROCE being the dependent variable and market concentration being the independent variable. Here the model is estimated with ROCE being the dependent variable and advertising intensity being the independent variable. ROCE being the dependent variable, advertising being the independent variable. Here the model is estimated with ROCE being the dependent variable, market concentration being independent variable, so is advertising intensity. So in this model there are two independent variables. Then here model is estimated with ROCE as the dependent variable, FTP as the independent variable. Foreign technology purchase. Like that it continues. Now what basically I would like to know, if you could observe some differences in the results as we switch over from one model to another. Only one thing I have done throughout the result sheet, I have kept the dependent variable the same, that is ROCE. And what I have done, I have basically altered the independent variable or the independent variables. So you take some time, maybe 5 minutes you take, and I would like to get a reply from you all how the results are differing depending on changes or change in the independent variable or the variables. So I'll stop here for few minutes and I would like to have an answer from you all.